All right, ladies and gentlemen, our next section of notes, we're going to continue on from our radicals. I'm not sure whose teachers completed the all of the notes from radicals or not. I know that my classes did not get to squaring or dividing, but I kind of covered a little bit in some classes. Please make sure we check out those videos, or we'll cover the squaring and dividing throughout these next couple weeks. We're going to talk about what geometric mean is. First, talk about the right triangle similarity theorem. This, we need to remember that the word similar, we call it the word similar, is going to have the same same shape, but we're going to have different sizes. Okay, same shape, different size. So here we have these three triangles, and they are all going to be the same shape, same size. We see these X's and Y's in different locations that are going to match up. And you also have a Z. So the theorem is, given that we have a right triangle, we're going to draw this altitude in here. Okay? So we're going to draw on the altitude to the hypotenuse. So from the right angle, 90 degrees, this is going to form this 90-degree angle right here. Okay? And this is the picture you're going to be seeing a lot of in this unit. We're going to be forming two more similar triangles right here that are going to be this big triangle, and these two also, all three are going to be similar. This right here, AD, is just where the altitude was. It just split them apart. So we can say in this picture right here that triangle ABC, the big triangle, so here, let's first look at this. Let's go ahead and see this in different colors. This triangle right here is just split right here. Okay, so these are going to be the two triangles. I'll be a little sloppy here. I apologize for that. And then the little smallest triangle right here is going to be this guy right here. So what we can look at is we can say that triangle ABC, the big triangle here, is going to be similar, remember it's similar, to triangle. Well, A on the big triangle is where the 90 degrees was. So on this one, if we're comparing to what I have in this little light orange, we need to go where the 90-degree angle is. And A on the largest triangle is going to correspond with D over here. Then B was the next one. We cruised down the long leg of this right triangle. So here from the 90-degree angle, we cruise down the long leg to get to B. And then down the hypotenuse to get to C. So here down the hypotenuse to get to A. So the second, or the medium triangle here, is going to be triangle DBA, where all our parts still correspond. Similar, we still need to have corresponding parts. We can also say that triangle ABC over here is similar to the smallest triangle. Again, A was where the 90-degree angle was. It will correspond with the 90-degree angle right here of angle D. So triangle, don't forget your triangle symbol. D, cruise down the longer leg. We're going to get to A. And then cruise down the hypotenuse to get to C. So we're saying the biggest triangle is similar to the middle triangle and to the small triangle. Well, that also means that, okay, and this is something we don't talk about with in geometry this year, but we do have different theorems and stuff. We're going to go ahead and we're going to go ahead and take these two now, and I'm not going to get into what the theorem is, but we're going to say that these two are now similar. Since these two are similar and these two are similar, that means these two automatically have to be similar. So we'll put in here triangle DBA is going to be similar to triangle DAC. So these two will also be similar. So we're going to take a look at this first one, and we're going to draw these triangles separately. Okay? So we're going to have our big, huge, ginormous triangle, right? The big main guy right here. Okay? And we're going to draw this guy out right here. We want to make sure that one leg does look longer than the other, okay, on this right triangle. Here we go. A little better now. We definitely got a longer leg. We have F up here, we have G down here, and we have H over here. And we're going to go ahead and draw, we're going to call this triangle. I'm going to go the same order they did. I'm going to start at the 90-degree angle, G, go down the long leg to H, down the hypotenuse to F. And then we'll go ahead and draw in our next triangle. We'll go ahead and go with our medium triangle right here. Okay, the medium dude. And we'll draw him out, making sure that one leg is longer than the other. There's our 90-degree angle. Where our 90-degree angle is J. So that's going to be triangle starting with our 90-degree angle J. We're going to cruise down the longer leg. So here, cruise down the longer leg to H. So there's H, and then down the hypotenuse over here to G. And our last triangle is going to be the small guy right here. So we'll go ahead and draw him out. Our 90-degree angle is going to be right here on the other side. Okay, so we've got J. So we'll have triangle J. I'm sorry, guys, rewind. I forgot to put G on here. Sorry, it's late in the afternoon. So we have J, cruise down the long leg to G, cruise down the long leg over here to G, and then back down the hypotenuse to F. Down here, the hypotenuse, F. So we've kind of rotated these other two. Unlike the one in the diagram above where they just split them apart, now we've rotated them around. Okay, we'll go ahead and not forget to put that F in there. So we're saying that all three of these are going to be similar. And we want to know which line represents the altitude. In the big triangle, we need to remember altitude means the first semester. And what it told us from above, we're going to go from the 90-degree angle across 90 degrees perpendicular to the other side. So we're looking at segment GJ. All right. This isn't going to be a huge thing, but it kind of helps you see when we look at, not this first part, but when we get to the second and third part here. Let's take a look at geometric mean. Your geometric mean, okay, is going to be two positive numbers, A and B. If two positive numbers, A and B, is the positive number X that solves, and I know this sounds really confusing, guys. You're not going to have to define all of this. All we're going to need to know is how to set this up and then what's going to end up happening right here. So all we're doing right here is we are cross-multiplying x times x to get x squared, and we're cross-multiplying a times b to get ab. In order to solve this, we've learned that taking the square root cancels out a square. So if we take the square root of x squared, it's going to cancel the square, but what we do to one side, we have to do the other. So that's where we come up with this x equals the square root of ab. So let's take a look at this. I'm going to do this a little bit different than my original notes because we're going to make this a little bit easier, okay? We're going to find the geometric mean of 24 and 48. We're going to put this in the simplest radical form, okay? The easiest way to do this is going to be with our factor tree. So we have here your geometric mean, A and B, as you see, are going to be the numbers. So we have A, just use it as the first number here, 24 over, always over x, is equal to that x repeats diagonally, and then 48 will be B. So we cross-multiply these. We're going to wind up with x squared is equal to that 20, well, actually, I'm going to do it like this. We're going to do 24 times 48. So then we have to take the square root of both, so these cancel, and we're going to get x equals, well, we need to factor all of these out. 24, we can factor as, let's say, 2 and 12. The 12 we could keep factoring to 2 and 6, and then that could factor to 2 and 3, and we have all prime numbers, so we're good to go on that one. 48, we could do 2 and 24. We could factor 24. We got it all right here, 2 and 12. And then 12, we can get 2 and 6. And then 6, we have 2 and 3. So this is why whenever I do it, I usually do the division tower with these numbers because this can get a little messy. We have to make sure that we do not forget all of these prime numbers up here. So when we go to do our radical house, okay, like what I've showed you in the radical video, we want to find all of our pairs to put outside. So I see a pair of prime 2's right here. They're going to go outside. I see a pair of prime 2's right here. They're going to go outside. They're going to join. I see a pair of 2's right here. They're going to join. And then if you look closely, you've got a pair of 3's right here. Another reason I like the division tower. And those guys are going to go outside. Let me draw a little squiggly line right here. Now, if you keep looking through all of these, you're going to notice this one little guy right here that is all by himself, that does not have a partner to go out to the three-legged race with. So he's going to go inside. Then when you multiply your 3 times 2 times 2 times 2, you're going to get 24 square root of 2. 3 times 2 is 6, times 2 is 12, times 2 is 24. And the square root of 2 is simplified, so there is your answer. Next, we'll take a look at this one. And this one I am going to multiply all the way out, the 15 times the 20, so that we can do our division tower. We want to find the geometric mean of 15 and 20, leaving it in our simplest radical form. And do not plug the square root into the calculator. We want to make sure we use our factor tree, our division tower, the perfect square way, whichever way you choose to do. So we have A and B. We have 15 over x is equal to x over 20. A over x equals x over b, we have right here. We cross multiply. We're going to get 8 squared, and we're going to show you if you do multiply all the way out. 15 times 20 is going to give you 300. When we find the square root, again, I want to make sure you guys see several ways of doing this. We've got the factor tree on this one up here, number 2. Number 3, I'm going to go ahead and show you that division tower again. So here's the division tower. I'm going to start with that 300, and I'm going to use prime numbers. You always use 2 until you can't use 2 again. Remember, 2 is our smallest prime number. So we're going to keep using 2 until we can't use it again. 2 goes into here 150 times. We can still use 2, and it gives us 75. We can no longer use 2. So remember, we need to use the very next prime number that we can. So move from 2. Can we divide by 3? Well, we're going to find out that, yes, we can divide by 3. So we're going to divide by the smallest prime number possible. We're going to get 25. 25 cannot be divided by 2. It also cannot be divided by 3. So our next prime number, remember some of our primes, 2, 3, 5, 7, 11, 13, so on and so forth. We can't use 2. We can't use 3. We can use 5, though. So we divide by 5, we get 5. When you're left with a prime number on top of the tower, you're done. So let's go ahead and figure out what our answer is going to be. X will be equal to, well, here's our radical house. I've got partners right here, 2. I do not have partners with the 3, so 3 is going to go inside. And then I do have partners with the 5, so those will go outside. Giving you a total of 5 times 2 gives you 10. No other numbers with 3, so you get 10 square root of 3 as your final answer. Now we're going to talk about geometric mean with altitude and with legs. Okay, this is a big, big part here. You need to understand there's going to be a pattern, like a little pattern going here. There's a lot of stuff going up in here. What I want you to remember is PAP. Okay, if you have altitude, I want you to remember PAP. You're going to have part over altitude is equal to altitude over part. Just like with the geometric mean up here, you will be cross multiplying. The bottom left with the top right will be the exact same thing, whether it's a missing number, a variable, or whether it's going to be an actual number. Okay? So here, what we're looking at, if you look at this part, this triangle right here, okay, and this guy down here, you're going to be looking at your part 1, and I'll go ahead and do this one first. Your part 1 right here, okay, over your altitude equal to the altitude of the second triangle, that's why we had to split apart, that right here, times your part 2. That is what the P's and the A's stand for. Now, if you're not going to have it separated like this, you don't need to. There is a pattern. Watch. Okay? You're going to start over here. You're going to go part 1. So you're going to head over here. You're going to go up the altitude to altitude right here. Up the altitude. On the other side, you're going to cruise back down the altitude over the second part. So all you're doing with PAP is you're just going over, up, down, over. Okay? You just whoop-a-doo. That's all PAP is. So when you see that altitude in the center of that large triangle being used, you are using PAP. Over, up, down, over. Okay? Now you might go the other direction. It may be rotated, but we'll look at some examples here. And we'll look at this example number 4. I am noticing here that I am using altitude. So because I am using the altitude right here where the x is, this tells me PAP, and you'll see the other one later, and how it doesn't even have A in it for altitude. So again, setting up our proportion, our altitude is going to be part 1, or with our PAP, part 1 over altitude, that same altitude over the second part. Okay? So again, it's just a whoop-a-doo. That's it, just a floopy-de-doop. So here we have part 1, the 6, over, roll up, altitude, the x, back down the altitude, x, over to the other part, 3. Okay, again, we just went 6x, x, 3. All over here, 6 over x, x over 3. Now we do our cross product. You see here we have x squared. This will be equal to 6 times 3, which would give me 18. We need to find the square root so that we can cancel that out. So I'm going to go over here, take my 18, I'm going to build my division tower. I can divide it by 2. I'm going to get 9. Can't divide by 2 anymore, so we go to the next one, 3. And I'm going to get 3. So in the end, x only has, we have one pair of partners, that is it. So we get 3, and we have one leftover guy to go inside the radical house for 2. So we have 3 square root of 2. So that's PAP. The other one is help. Okay? Help is dealing with the legs of your triangle, your right triangle. This is HLLP. Okay? So what happens with HLLP, I'll show you just directly with this guy right here. This is when you're not using that altitude. When you have everything else marked or other things marked, but you do not have altitude mark, or you don't even have it in the picture, you're not using PAP. There's no A in here for altitude. Okay? So what this is, I'm just going to be able to show you one of these really, but here we have our hypotenuse. So here's your hypotenuse, and there's a pattern to this one too. You have a hypotenuse over the leg that you're trying to find, or the leg that you're given. Okay? Then you use that same leg right here, and now you're using the part that goes with that leg, that connects to the leg. Okay, so you have these two parts. Look at this, leg 1 and part 1. Over here we have leg 2 and part 2. Okay, so you're looking at which pieces are we using, and there is a pattern to this. You start over here at C, you're just going hypotenuse, up the leg, back down the leg, and then just part way. Okay, so you're just going boop, 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 boop. That's it. One straight line for both of these. You're not jumping over here. You're going one straight line. You don't even have to pick your pen up to go that distance. Okay? The same thing will happen if you're looking for the other side over here. So let's take a look at finding the value of y. Notice that the altitude right here is not marked. So here we can note no altitude. So this means we're using help. So here we're going to use our hypotenuse over the leg that we're using, that leg repeated again, and then the corresponding part. Okay, we'll just go ahead and call these leg 1 and part 1, that corresponding part. So even though this is rotated, no big deal. Start at the opposite side of the hypotenuse than the leg we're going to use. Okay? Again, I want you to watch this pattern. We start at the opposite side of where this leg is. We're going to go hypotenuse. Okay, hypotenuse. Now keep in mind, we have a part split up, so we're going to have to find that by saying this is 7. H, your hypotenuse, is 7. So you go hypotenuse, 7, over the leg that we're trying to find, or the leg that they give us, y, back down that leg to the hypotenuse, y, over just this part right here, 2. Okay, so again, we went one straight line. You just take one straight line. You start over here, the opposite end of the hypotenuse than the leg we're using. You just one straight line, hypotenuse, leg, same leg, that part. We did not pick up our pencil. Everything stays over here. Okay? So again, we'll do our cross product here. And we're going to find ourselves with y squared is equal to 7 times 2 is 14. Now, when we go to take the, sorry, I did not put the, yeah, that's 7, sorry. So whenever we go to solve this, we're going to find the square root here, cancel, square root here. Well, when we take 14 and we try to build our tower, we divide by 2, we're going to get 7. 7 is another prime number. This tells us the square root of 14 is already simplified. So y is just going to stick with being the square root of 14. All right? And then we'll move on to the last problem and see what are we looking for, help or PAP. So on the next part, we have that the cost of installing rock wall in your school gym right here. To find that cost, you need to find the height of the gym wall. So we're looking for this entire height. So you'll notice here we're looking for the hypotenuse, because they went ahead and extended it out to here to show you everything. Okay. What we're going to notice is we are using right here the altitude. So because we're using the altitude, we need to note we are using altitude. So looking at help and PAP, the only one that has an A in it is PAP for altitude. So we're going to use PAP. Okay? Reminding us that our PAP is going to be your part 1 over altitude, altitude over part 2. All right? So let's take a look at what this is going to look like. First, we have our part 1, okay? Doesn't matter which one's part 1 and part 2, guys. It really does not matter, whether it's the W feet or the 5 feet. I don't care. We're still going to follow that same pattern of going down the hypotenuse, whoop, up the altitude, back down the altitude, finish off that hypotenuse. So we're going to have part 1 right here of W times altitude, up the altitude, 8.5. We're going to go back down the altitude, so we're going to have another 8.5. So this diagonal will always be the same thing. This time we don't have a variable, we have a number. That's okay. And then once we go back down the altitude, we finish off that hypotenuse with the other part of 5. So we'll do our cross product here. And we're going to wind up, go ahead and solve this. We're not going to be doing simplest radical form. We're just going to get a decimal in the end on this one. Go ahead and solve it. I'm going to pause it, and then the work's going to show up. Please pause your video now. All right, about to uncover it. Make sure you have done it on your own. This should have been your answer, 14.45, 14 45 hundredths. If you did not get that, please check your answer. Please check your work. Just 2 simple steps, multiply and divide, and that is geometric mean.